This walking talking mock is best used with the mock question paper, so please make sure that you download this before beginning. This mock question paper is only based on 3.1.1 of the specification, which is to do with the representing algorithms section. When you're starting an exam, you need to make sure, first of all, that you look at how many marks are available. So I'm going to go right down to the bottom. It usually says this on the front of a real exam paper, but I know mine's there. So it's out of 13 marks. That means that I have roughly 13 minutes to take this test, and I should be spending 1 minute on each mark. So this first question here, define the term algorithm, I know I shouldn't be spending any more than 1 minute taking that question. But when I go down here, I've got a much longer question here, which is worth 7 marks. So I know I should be spending around 7 minutes on that question. And then down here, I've got one worth 2 marks. So that should be 2 minutes. They're just some simple tips that you should bear in mind when you are doing your mock exams. The next tip for taking examinations is to be aware of the different command words that are used. Now, define is a popular command word that is used in a lot of exam papers, and it just means specify the meaning. And it also says on there that it's worth 1 mark, this question. This means it's not looking for a big, long answer. It's looking for a very specific, short, sharp answer. So define the term algorithm. You should know this by now very, very well, that it is a set of instructions that end with the problem solved, and that would get me my 1 mark. Now we've got the word define again, and this time we're looking at abstraction. So abstraction, again, it's 1 mark, so I've got to bear that in mind. Just want a simple, sharp, to the point answer. So abstraction, I was going to say removing, but it's hiding unnecessary detail to make solving a problem simpler. Okay, next one, we've got that word define again. This time we're looking at decomposition, and it's worth 1 mark, so we're looking for a short, sharp answer again. So decomposition, breaking a problem down into small, manageable chunks. Now, I'm not being marked on my spelling, but I would love to be able to check those 2 words. Okay, just to make sure. Those come up quite a lot, so it's worth figuring out how those actually are spelled before you start taking an actual mock exam. Question 4 gives us figure 5 showing the start of an algorithm. So we've got to look here at this section. So it gives us that as our clue. Now this is a long answer question. It is worth 7 marks. You should spend around 7 minutes on this question. It's a really important one for you to try out. Now, if you struggle with this in the exam, even if you only get half of it right, that's 3, possibly 4 marks that you can get. So it's always worth attempting these questions as best as you can. So let's have a look at the question. You've got there, the algorithm in figure 5 asks the user to enter a number between 0 and 23. So we can see that output, enter the 24-hour number from 0 to 23. So our user input there. So we're putting some user input and we're saving it in a variable called hour. Extend the algorithm in figure 5 using either pseudocode or a flowchart so that it outputs the equivalent time using the 12-hour clock. For example, a number between 1 and 12. Follow by either AM or PM. Then you've got there some examples. If the user enters a 0, the program should output 12 followed by AM. If the user enters 4, the program outputs 4 followed by AM, and so on. It says there you can assume that the variable hour is an integer and that the value that the user inputs will be between 0 and 23. So it's telling us really that we don't need any error checking going on with our data entry that we've got going on here. So you've got a few things to think about. We've already got this start bit, which gives the user the instructions and it stores something in a variable, and then it wants to output something on the screen. So we know we're going to need output again, and it's also giving us some clues here. Hopefully you'll recognise that word there, if. So we're looking here for some kind of if statement. And we've got here, you can assume that the variable hour is an integer, so we know we're working with integers. The value the user inputs will be between 0 and 23. So we're using if statements, and we're doing something with the 24-hour clock. Now, the 24-hour clock is something that you may not be aware of, but if you're not aware of it, the numbers start at 0, which would be midnight, so that would be 12 AM, and then when we go to 1, it's 1 AM, all the way up to the number 12. 12 then becomes PM, which is the afternoon, and that would be 13 o'clock. No, sorry, 12 o'clock. Okay, then the next one would be 13, which would become 1 PM. 14 would become 2 PM. 15 would become 3 PM. So that's roughly what is happening here in these examples that it's showing us there. So if the user enters 15, it should say 3 PM. So we've got different things that we can do here to solve the problem, but I like to just get things jotted down so that I can see where I've got to go with this. So the algorithm in figure 5 asks the user to enter a number between okay? Extend the algorithm in figure 5 using either pseudocode or flowchart. I'm going to use pseudocode so that it outputs the equivalent time using the 12-hour clock, i.e. a number between 1 and 12. So I'm going to think now, well, what would happen? So if they put in a 0, so if hour equal 0, then the output is 12 AM. So we've got this chunk here, we've got this chunk here, and we've got some kind of condition that we're checking here. Now, it would be inefficient for me to go through every single number on here, But I could do that if I really wanted to. I could do if hour is equal to 0, then 12 a.m. If hour is equal to 1, then 1 a.m. If hour, I could do that if I wanted to, okay? But I'm not. I'm going to think about it a little bit better than that. So I've also got some other options here, because if it's between 0 and 11, then it's AM. So it's 0 to 11 is AM, and 12 to 23 is PM. So that could be something that I store somewhere. By the way, this is a bit of abstraction and a bit of decomposition working together. Okay, so that's the computational thinking skills that I'm using right now. So I've got here 0 to 11 is AM, 12 to 23 is PM. So I could do a check first of all, just to see whether it's AM or PM, and store that somewhere. So I could have a variable and call it AM, PM if I wanted to, and I could just default it as some string, and I could do if hour between 0 and 11 AM PM equals AM. Now another option is to use true or false. Is it AM, true or false, and then change between the two. But if this makes more sense to you, then elif hour between 12 and 23 AM PM equals PM. So that's going to give me whether it's AM or PM. Now within that, because I've already started to look at the different sections there, what I can do is I can think, well, I could add another line of code in here and another line of code in here. So let's think carefully about what will happen when it's 0 to 11. Now when it's 0 to 11, the number does not change. So we could just directly then output hour plus AM PM. Okay, now we could put their string in front of that, but because it's pseudocode, it doesn't really matter at this point, but you might want to put that in just as an extra. Now this one, when it's in the afternoon, these numbers change because no, 12, I've got this wrong again. Look, look up here, I've done this to remind myself. We've got a little thing here which is going to be annoying, because when it's 12, it's the afternoon, but the number doesn't change. So what do we do about that? We could put in if hour equal to 12, then output hour plus AM PM. That would solve that problem, but I'm sure there's a much more efficient way to do this. Okay, then we've got our 13, etc, etc, all the way across. So now we've got a little bit of maths to do, thinking about how do I get 13 to be 1 and 14 to be 2. So 13 is 1, 14 is 2, 15 is 3, 16 is 4. What maths is happening there? What pattern is happening? That's what we've got to look for, pattern recognition. So from 13 to 1, we are taking away 12. From 14 to 2, we are also taking away 12. From 15 to 3, we are also taking away 12. From 16 to 4, we are also taking away 12. So there's our pattern. It's taking away 12. So for this one, we'll have there at the end an else output hour minus 12 plus AM PM. And that does solve the problem. Now, because I'm a neat freak, I would now write this out again nice and neatly and specifically somewhere else. You'll have lots more room to write on your exam papers, but this is what we're doing. We're going to have a look at the marking criteria in a minute just to see if it went wrong anywhere or if I've missed anything out. It's a really, really good idea to just check through the question again and just check that with your pseudocode or your flowchart that you've written there. So I've got there the algorithm in figure 5, we know that one. Extend the algorithm using pseudocode or flowchart so that it outputs the equivalent time in the 12-hour clock, blah, blah, blah. As far as I'm concerned, I feel like I've answered this question now, so you can assume that the variable hours, blah, blah, blah. Yeah, I feel like I've done it. Let's just have a look. It's out of 7 marks, so I would imagine you're probably going to get a mark for having a variable to store AM or PM. You're probably going to have a mark for if this is true, another one for if this is true, outputting the right thing, outputting the right thing. So I can probably see 4 or 5 marks there in my answer, just to sort of give you a bit of an idea of how it might be marked. So let's go and have a look at the marking criteria to just see exactly how this question was marked now. So here's the marking criteria, and I've already spotted 1 mark that I've lost here, which is a little bit frustrating, but this is why it's important to really thoroughly check every part of your pseudocode before moving on. So here we go, 1 mark if it outputs 12 AM if the input is 0. So let's have a look here. If hour between 0 and 11, then it outputs the hour with AM. So it would have done the AM, but it would have put 0 AM. So that would have been wrong. So I'd have got a big fat cross on that one. So 1 mark if it outputs 12 PM if the input is 12. So we got this one right, because I remembered that one by writing all those numbers at the top. So I've got that mark, yes. 1 mark for selecting just the inputs 1 to 11. I won't get that 1 mark because I did put 1 to 11, I put 0. That's annoying. 1 mark if it outputs 1 AM to 11 AM correctly, given the corresponding input 1 to 11. Yes, I will get that mark because that would happen with this algorithm. 1 mark for selecting just the inputs 13 to 23. Now this is a little bit confusing here because I've done my algorithm differently, so I'm not sure if the examiner would give me that mark now I think about it, because I've done it slightly differently. Then 1 mark for adjusting the value of hour to be 12 less, so I've got that, I've got the subtraction there. 1 mark if it outputs 1 PM to 11 PM correctly, and yes it will. Just a bit iffy about this one here, but I reckon the examiner would give me that mark because I've embedded this if statement within that one. So I'm going to say I got that mark. So I've got 5 out of 7 on that one. Moving on to question 5 now, we are given a short algorithm that's showing a subroutine that returns a value. So I would hope that you would know that this is a function because it's returning a value. And the question that we've got there at the bottom, what value is returned by the subroutine call total out x0, where x is any positive integer? So let's just break that question down. We've got here what, so that's a bit like a command word there. It just wants a very specific answer. Again, your clue there is in your 1 mark. So we've got what, we've got 1 mark, so it wants a very specific, short, sharp answer. And then the other thing is, what is a positive integer? You should know that an integer is a whole number, so we also want it to be positive, so it shouldn't be a minus number. It should be 1, 2, 3, etc, etc. So it's any whole number. So it's saying here what value is returned, so what will happen here, by the subroutine call total out x0, where x is any positive integer. So if I want to test this out, I could just try and guess it and think, something going on with that 0 there that seems quite special, possibly. But let's just test it out. So let's see what happens. So we've got here number 1. Let's just put a 1 in x. So if we want to pass 1 and 0 through this subroutine, we would make sure that we've got up here a 1 and we've got up here a 0. So it's always good to just write that on the question paper so that you know exactly what you're doing there. You could do it in pencil if you want to rub it out, but it doesn't really matter. So we've got here C is A plus B. So A plus B is 1. Okay, so we know now that we've got a 1 stored in there. Okay, then it says while A is less than C. So to make this true, A needs to be less than C. So A is 1 and C is also 1. Okay, so this is where hopefully we're getting a bit of a clue now as what might happen. All right, so here we go. So C we know is 1, A we know is 1. Can A be less than C? So A is 1, C is 1. Can A be less than C? No, it can't. So this while loop will not run in this situation. So B will be returned and B is 0. So 0 will be returned. Now, I could just do that with my absolute confidence, thinking, yeah, that's definitely right. But it's worth just testing it out on another positive integer just to make sure. So if I was going to put now a 2 and a 0, we know it has to be a 2, we know it has to be a 0. Okay. So if I do it with a 2 and a 0, if I go here, C is equal to 2 plus 0. So C is equal to 2. So now it becomes 2. So while 2 is less than 2 doesn't work. So all this code isn't going to run. It's going to go straight to this line of code here and it's going to return B, which is 0. Okay, so I'm pretty confident now that the answer is 0. I do not need to spend time in my exam writing a full sentence because all it wants to know is that number there, 0. Okay, so don't waste time writing it all out as a full answer. It's for 1 mark. It's not telling me it's looking for my spelling, my grammar or anything. It just wants to know what value is returned. And the answer is 0. So this question is also connected to figure 2 and we're looking at this time what is the purpose of the algorithm in figure 2, and this time it's worth 2 marks. So we're going to be needing to put at least 2 points here to our answer. So what is the purpose of the algorithm? So I'm just saying, what is this algorithm actually doing? So we've got here, it's a subroutine. So it is a subroutine that passes 2 arguments A and B. It then performs calculations performs calculations and returns the value of B. So that's just 2 points to do with that algorithm, and I've said what the purpose is. So it's a subroutine, passes 2 arguments, there's your 2 arguments, A and B. It performs calculations, that's what's happening here, and it returns the value of B. So there's my 2 mark answer to that question.